In this lesson, we will look at the concept of randomness, which we will add to our games and to our knowledge. Why do we need randomness? Well, sometimes in games we need a random character to appear, or for some random action to happen. For example, whether a character attacks you or not, or maybe we need to draw a random card. So, we need to figure out how we're going to get these random values. Let's jump straight into practice. Just like last time, we go to the online CPP website, where we'll actually run our program. You might see a window pop up there, just like last time. You might not see it because it only pops up when ad blocking is enabled. And this is the default program that the editor gives us. How do random numbers work? For this, there's the rand function, which comes from the English word random, which in turn comes from the Ukrainian word random. Like a random guy or a random event. I'm just joking, because otherwise people in the comments will roast me. So the rand function, let's use it. We remember from last year that we have this structure, count, 2 arrows, and then we enter some values. And let's output riot. This function returns a large random number. Let's take a look. Here we got some big random number. Let's repeat this line 3 times to see 3 different random numbers. I'll just copy it 3 times and run it again. As you can see, we got a really big random number. Why is it the same one? Because we forgot to move to a new line. How do we do that? As we remember from last year, we add, again, 2 of those arrows. And we write end, meaning end of line. And we do this in every line. Endel, right? And here, end. Let's run it. Now we see 3 random numbers. But as you noticed, these 3 random numbers, they seem random, but if I run it again, they'll be the same. Why does this happen? Actually, this rand function doesn't generate truly random numbers. It generates so-called pseudo-random numbers, random numbers. The idea is that each subsequent random number depends on the previous one, but the whole sequence looks random. For games, that's usually good enough. So how can we make these random numbers different? For that, there's a function called srand. So the S stands for seed, basically like a starting point. It's a value that serves as the base for the next random numbers. All right, let's write srand and put in some number, 1, 2, 3, 4. And let's run it again. As you can see, now it's a different sequence of random numbers. But when I run it again, this sequence repeats itself. This is actually very useful. It's often used when generating maps. In some games, you've probably noticed that when you generate maps, there's something called a map seed or a map code, which lets you take that code and generate the exact same map. This works basically in a similar way. We start generating numbers from a specific code, and then each cell calls a conditional rand function, which looks random, but all these random results are repeated exactly the same as in the previous map generation. So you only need to know one small number to generate an absolutely identical map with a large number of random variables. That is, there are some random rivers, mountains, valleys, some resources, and so on. All right, so how can we make it as random as possible so that every mountain is unique? What can we use as a seed? We can use the current time. And for this, we have the time function, which we need to pass. Parameter 0. What is this 0 for? For now, it doesn't really matter. The main thing is just to remember this construction. We call the srand function, passing the time function in parentheses, and that's why we end up with these nested parentheses. The srand function takes this value as its parameter, time 0, and time 0 is another function that has its own parameter, 0. What does this function do? It takes the current time in milliseconds and uses it as the starting point for generating random numbers. And that's why, basically, every time we run the game, the numbers will be random. See, right now it's one sequence, and now it's a different sequence. Basically, we've achieved our goal. And now we have numbers that are random. A very attentive listener might ask, what if 2 users launch the program at exactly the same time? If 2 users launch the program at exactly the same time, down to the millisecond, then they'll get the same random numbers. There are some nuances. Now, let's move on to the next interesting question. And let's make a program that will generate a random number, either 0 or 1. How can we do that? Let's recall some math. I don't know which grade it was. Write it down below. The topic is remainders of division. To get a number that's either 0 or 1, we can take a large number, divide it by 2, then take the remainder. The remainder when dividing by 2 is always 0 or 1. And if we take the remainder of a large random number divided by 2, the result will be a random number, either 0 or 1. Let's implement this. Let's create a variable. And as we remember from last time, first we need to write its type, int, which stands for integer, a whole number. Then we need to name the variable, for example, result. Next, we use the rand function, which, as we already know, returns a large random number. And we'll take the remainder when dividing by 2. For this, in C++, we have an operator that's represented by the percent sign. And then we write 2. We put a semicolon at the end. As always, every statement must end with a semicolon in C++. Let's look at this expression. We take a large random number, and we take the remainder when dividing by 2. Let's print it to the screen. What do we do? As we type on the screen, we remember. We write count, 2 arrows, changes to the result. 2 arrows, indel, semicolon. These 2 lines can now be deleted. We don't need it. And we launch. Yes, we made some kind of mistake. I wrote count, but I should have written coot. Cut. Yes, coot, like that. Let's launch. We see 0. Let's run it again. 1. Let's run it again. 0. Let's run it again. 0. Well, you see, these are random zeros or ones. And finally, let's do some checking. Let's write a condition. Let's remember that the condition is. That a condition is if, then in parentheses, we write the actual condition. We need to compare the result we got, which is the variable result. We need to compare. As we remember, we compare. Let's compare it to 1. If it's 1, we'll write that the user won. As we write count, 2 left arrows, you won. And then again, 2 arrows, end. Otherwise, it's the else operator. We write count, you lost. Again, 2 arrows, endia. That's right. You won, we see the result. You won, you lost, you lost. Well, what do we have here? Basically, it's a little mini game that you can play really quickly. If you have a bit of time, please sit down, just 1 second. You already know whether you won or lost. That's it, you played. You are free now. You can certainly get back to your very own unique storyline. For example, you can make it not just win or lose, but say make it about burning. Loves me not. You can add more options. We made 2 options there. You can make 3 options or 4. You can make a playful version of a raw card where you'll have lots of options. The program will do a humorous fortune telling. Besides that, you can check out how we did it in the previous lesson. In the previous lesson, we learned how to get data from the user. You can set it up so that the user tries to guess. And what did the program come up with? For example, the program flips a coin. It's either 0 or 1, heads or tails, and the user has to guess what exactly the program picked. So today we learned how to generate random numbers, what a random number seed is, more or less clear, I hope. And we wrote a very simple program where you can quickly find out if you won or lost. I'll see you in the next lessons.